Okay, so let's start the session. So welcome everyone to the third part of the webinar series on Sunbird RC. So in this webinar, we'll be we're quickly talking about a technical deep dive into Sunbird RC. So here we'll be talking mostly about how Sunbird RC can be installed locally and how do we create schemas and how do we test all the APIs and generate entities for the respective schemas. So quickly we'll introduce ourselves. So myself, Tejas, I'm working at Sahaj Software as a solution consultant. So I've been uh, contributing to Sunbird RC for the last 2 years. I also actively worked on setting up the DiveWalk instance. Basically, it was using Sunbird RC behind the scenes. So for people who don't know about DiveWalk, DiveWalk is a framework which has been used to generate COVID vaccination credentials in India and also in few more countries. So that's about me. I'll ask Ashwin also to introduce himself.
Yeah. Hi, my name is Ashwin. I'm the CTO and co-founder of TechD Technologies. TechD has been contributing, volunteering to build Sunbird RC, and we've also been deploying Sunbird RC in a host of use cases. So, just a quick thing about today's session. So, while the last two sessions have been largely uh, more about the business side, more about the use case capability side, today we are doing a deep dive into the tech aspect. So things like creating schemas, how to initialize a registry with schemas, and once you do that, seeing what kind of API capabilities get created out of the box. So that is going to be the core part of today's session. Over to you, Tejas.
Okay, cool. So let's continue. Let's see what is the agenda for today. So we'll just quickly give a small walkthrough about a quick introduction about Sunbird RC, and we'll talk about what is schemas in context of Sunbird RC. How do we create schemas? What are the configurations that are required to build a schema? And after that, we'll move on to completely an hands-on session on how to install registry, the complete Sunbird RC stack onto your servers or onto your systems. And also we will talk about how quickly about setting up the demo education use case. And finally, we'll execute all the APIs around that, create students, teachers, and test all the APIs. So moving on. Okay. So quickly, just we'll give a quick introduction about Sunbird RC for folks who have joined newly to this session. So what is Sunbird RC? Sunbird RC is a low-code, no-code framework which helps you to build a live registry. Um, so Sunbird RC is completely open sourced and built on MIT license. And these are some of the components which Sunbird RC offers. So basically, Sunbird RC R stands for registry. So where you can create a single source of truth data. So all of this registry schemas can be created without doing any coding. Just create a schema and all the REST APIs around the schema will be auto generated and can be used. So discovery APIs will be exposed and analytics will be generated out of the box. So C in Sunbird RC stands for credential. So Sunbird RC can be used to generate verifiable credentials. So we follow W3C specifications to generate verifiable credentials. And it can also be independently used just to issue and uh, just to issue the verifiable credentials as well without the registry. So Sunbird RC is actually built in a modular component, so you can always plug and play the various services that it provides. So these are the major components of Sunbird RC.
Yeah, and
So
just
we'll
to add
quickly.
to that, you mentioned DiveWalk, right? So DiveWalk actually is probably one of the largest implementations of Sunbird RC, and they're using it in a mode where it's purely used for VC issuance, right? So
Yeah. So we'll talk about the different components, what Sunbird RC provides, a high-level architecture that what it defines. So Sunbird RC at the core, we have so the complete Sunbird RC is written in Java and it's an independent service that can be deployed. Along with this, it comes with multiple other services that can be used based on the business use case. If it is required, you can use it or you can skip in setting up that service. So we have registry core that basically exposes all the APIs to create schemas, creating entities, and discovery APIs and all of it. So just to run the registry part of the Sunbird RC, just the registry core and DB is sufficient. Other services can be added based on the requirements. For example, claim MS can be added if your business use case requires attestation workflows. Similarly, certificate signer and certificate API can be added if verifiable credentials needs to be generated. And notification MS can be added if you want to send out any SMSs or emails to the users whenever there is an invite or whenever you need to send out OTP SMS or anything. So we have built a generic notification layer, which can be plugged into third-party providers, and that can be used to push out SMS or emails. So then we have public key service, which basically exposes the public keys that are basically used for generating the verifiable credentials. And we also have a context proxy server. This is used behind the scenes, basically to proxy your context URLs. So people who have used W3C would be aware of W3C would be aware of that each verifiable credentials contains something called context URLs. So when a public-facing client is accessing those context URLs, so that will be blocked for CORS errors. So to avoid that, we have provided a context proxy layer, which kind of proxies those requests through this service, so you can avoid the CORS issues. So on the left-hand side, you can see what are the other third-party services that we are using. One is the DB. So Sunbird RC kind of can work on multiple databases. One is MySQL, Postgres. It can also work on Cassandra and also on OrientDB. It can also work on Tinkerpop. So these are different databases that it can work. So this is the main source of data that will be stored here. Along with this, we have support on Keycloak. So basically, Keycloak is used here to basically provide authentication and authorization services, and also as it's been used as an identity layer. So we're also building to provide a support to be more generic to support any OAuth services. So that is still in roadmap, but right now Keycloak is a dependency. Then we have Elasticsearch, which enables the discovery functionality. So all the read searches, everything is being realized by the Elasticsearch service. So then we have Redis. So this is helping us to cache few data that is being required for the registry when you are basically running it in a distributed mode. We also have async functionalities. So if your application needs to work like in India population scale, so you might need a distributed system and it should work in asynchronous mode. So we also have a support to run using Kafka, so where you can automatically run creating entities in an asynchronous fashion. So we are also providing a support to store any files or any informations like a blob storage. So we have support for MinIO, which is an S3 compatible storage. So this has also been supported to store any documents for a schema. So we also provide with an Nginx, a little bit of customized Nginx layer for someone who want to proxy all the requests to the services, right? So all the reverse proxy routes, all of them have been configured and a generic Nginx Docker image is provided. So that can kind of cover, or instead of directly kind of providing a public access, so all the requests can go through this Nginx route. So these are the high-level components. So to run just the registry component, just registry core and DB is more than enough. And other components can be added based on your use cases. So just to add on, if you have any questions, please put it onto the QA section here so the team can answer them in meanwhile. Yes, Ashwin, over to you.
Yeah. So now what I'd like to quickly run you through is how would we be running this demo or this kind of session today. So what we're doing is that we are using a very simple education use case, and it's a super simplified use case. Sunbird RC can do pretty complex use cases. So it's a super simplified use case where we will be covering entities like institute and teacher and student, and show you how to create a schema, how to upload the schema, and how to start the registry with those schemas, and how APIs get created. So before we get to the super simplified version, I'll just walk through in a few minutes how we see the education use case coming out. So there are four key stages here. So it starts with the onboarding stage, where let's say to begin with, a board is onboarded. Let's say a CBSE board is onboarded, and then the board invites the institutes under their affiliation to come in and register onto the platform. And once the institutes are registered, they send an affiliation to the board. They send a claim to the board, and the board attests that claim, which results in a affiliation, and then this affiliation can result into a VC. So then the institute can actually present this VC to anybody who wishes to see it, which verifies that this institute is affiliated to the board. Similarly, teachers can sign up and they can send a claim where the institute can attest that yes, this teacher is actually teaching at the institute. And similarly, in case of students, a student can sign up and send a claim that they are studying in the institute. So this is the onboarding part, and also the part where claims are being sent and the claims result into VCs. Then there is a part where, depending upon what kind of fields or depending upon attributes being defined, automatically we get access to the public profile of institutes, where all the fields that are marked as public are visible for anybody to see. And then the last step is verifying the VC. So anybody who wishes to verify any VC can access the VC itself, and can access the APIs that have been provided to also uh, uh, verify the claim. So this is a use case. Of course, there's a lot of stages here. So what we'll be covering, if you can just move to the next slide, Tejas, is we'll be covering a very simplified design today, where we are just talking about 2 to 3 entities. We have a central institute entity which is signing up, and then once the institute signs up, we will have a teacher and a student signing up or being invited by somebody. And we'll have, I mean, we won't be looking at claims today, but once these entities are there, we will be able to briefly show how associations can be brought out. And in the next few webinars, we will go deeper into claims and VCs. So these are like very simple three schemas today that we'll be using all through the demonstration. Just putting the slide here so that when Tejas gets into the details of the schemas, you know what schemas we'll be creating. All right, over to you, Tejas.
Yes. So before setting up the registry locally, so we'll just quickly talk about what are schemas, how do you define a schema. So to create a schema, so we are following a JSON schema specification. So it is more declaratively where you write how your JSON should look like. So for example, here there is a schema that is defining a person registry. So basically what details we're trying to store here is first name, last name, and age. These are the three parameters. So when you want to define a schema for this, so you need to specify what are the properties. So I'm saying first name, the type of it is string. So we support JSON schema supports commonly known data types like string, integer, number, boolean, objects, arrays. All the basic data types are supported. You're basically defining the types here. So you're saying first name should be type string, last name type should be string, and age should be an integer. Along with this, JSON schema also allows you to add basic validations. So in this example, I've shown you like a minimum age should be 0, so age cannot go negative. So you can always put some certain validations for your properties. Even the name, if you have a condition saying that the minimum length of the first name should be at least 1 character, so you can say a minimum length should be 1. So whenever the schemas are getting created, if these validations are not properly satisfied, the errors will be thrown. So we'll show that demo as well in the coming. Uh, so let's move on. So basically, these are the data types that JSON schema supports: string, number, integer, object, array, and boolean. So along with once you have defined the schema, so Sunbird RC provides few configurations for this schema. So some of the schema configurations that it provides is the visibility scope. So we provide three types of visibilities on the attributes. So one is public. By default, all the fields that has been defined in the schema are public. When I say public, What it means is, so the Sunbird RC provides discovery. So basically, anybody can search through the data. So all the public fields will be accessible through the search API. So if you want to restrict that certain attributes, maybe phone numbers, email IDs, or any other personal information should not be shared outside the user's ownership. So then we need to specify the private and internal. So we have two specifiers. When we say private, it is not publicly available, but it can be accessed via a consent permission. So the third party should raise a consent request, and the owner of that data should approve or can also deny it. So once he is approved, the private fields can be accessed by the third party services. When it is mentioned as internal, it cannot be accessed via any other modes. Only the owner of that entity can access this part of the data. So we also provide configuring if you require an index field. So based on your use cases, sometimes you might be searching across your data on your registry on certain fields. So if you want to optimize your searches, you can add an index. So it could be a single field or it could be a composite field. Also, we support unique index field. Basically, if you want an index to be applied along with an unique constraint, you can mention the unique index field as well. So this will throw up error if there is a duplicate constraint being violated. Then we can also mention the roles. So roles will allow you to add authorization to your APIs. So if you want your APIs not to be anonymous, and if you want to introduce authorizations, and you can specify those roles here. So for example, a teacher entity can only be invited by a institute. So which means that nobody else can anonymously kind of create an invite to a teacher. So these kind of rules will walk you through the next set of when we do the live demonstration. I'll show you all of this in real time. So then we can add login or ownership details. So when an entity is created for a schema, so we can automatically generate login details so that user from an UI can log in and use the token to access their information. So the fields for that ownership details needs to be configured. So then we'll also configure attestation policies. So basically these are workflows where you can configure. For example, let's say a student wants to prove that he graduated from an institute. So what basically the student will do is he'll raise an attestation request to the institute. The institute will verify that details from the record books or from the registries. And if it is a valid request, it can be granted and a verifiable credential can be generated. So these kind of workflows can be created through the schema. All of this can be added into the schema configuration. Then we have credential template, basically which allows you to attach a W3C based template. So for that schema, it will also generate a verifiable credential. Then certificate template is basically where you can define all your visual templates that will be required. So using these templates, you can create any PDF or SVG or HTML based templates to visually represent your verifiable credential. Basically a presentation layer for your verifiable credential. So now moving on, the next complete session will be on completely hands-on. So I'll just give you an high-level prerequisites, what will be required. So you'll need Node.js, Docker, and Docker Compose to be set up on your instances. So these are the three main requirements here. So then you can install Registry CLI, which is a command line interface to set up the registry in one command. So you can install it using the npm command, npm install global and registry-cli. So this will install a registry locally. This is just for the command used to set up the registry. So moving on from here, so I'll just quickly show how to set up the registry CLI completely from scratch. So moving on to my terminal. So just verify that you have always installed the latest version of the registry CLI. So you can check it in the npm package or even in our GitHub repos. So the latest version is 1.6.4. So this is the latest one. So then to initialize the registry locally, the command you need to run is registry init. So if you just run registry init, I have actually run it previously itself, so that this will take around 2 to 3 minutes of time based on your local system configurations. So I have run it and kept it ready. So once you trigger registry init, so this will ask you few questions. So one is, what is the name of the registry? I'm saying it's education. And if it'll ask you what should be the realm name that it should create. So you can mention a specific name for it. So here I'm saying education. So then an admin name for an admin client. So I think people who have used Keycloak will be aware of these terms. So we need to create a client, an admin client. So basically this will be used to create users and other roles and permissions in Keycloak. So what should be the name for that client? And a front-end client. So basically this client can be used by any one of your front-end applications to generate or to basically navigate the user to the respective login pages. And it will basically ask you questions for entering your username and password for the admin account for Keycloak. So I've given default admin and admin. So then it'll ask you which path should be used to read all the schemas that will be required. So I'm continuing with this default values here. So what happens when you go with the default values is this command will feed in this setup with few sample schemas. So you can use those sample schemas to test out, play around that, and test all the APIs to get more familiarized. Then it also asks for the file path for the consent configuration. So I'm using the default. In the coming webinars, we'll be talking about this more about this consent and the attestation workflows in the coming webinars. So in this webinar, we'll be focusing only on how to create schemas, how do we create entities around those schemas. So this would take around 2 to 3 minutes. So once it is successfully installed, you will see some message like this. So once this is done, you can run registry status, which will quickly show you the complete status of all the services that has been installed locally. So we are using Docker and Docker Compose. So here you could see all the services and their status. Make sure that all of them are in running state. So if you see all the services that we showed it in shown in the high levels architecture, all of them are running here. So in most of your scenarios, you might not need. So you can go ahead and stop some of them if it is not required for your, maybe like Keycloak and all of that will not be required for your kind of a demo instance or for the instances that you are trying out. So you can just stop those using the Docker Compose commands. So now once this is done, so I'll quickly show what all files are present in this particular directory. So you can run registry init in a completely a new directory. So this will create few files inside that directory. So I'm just listing out all the files that are present here. So you can see that there are few files the registry command has created here. So like I said, it has created few sample schemas here. You can see in config schemas. So there are two sample schemas that it has created, like student and teacher. These are very basic schemas that has been created here. So I'll just show one of them. So this is a basic schema for a student, which has just 3 to 4 parameters like name, phone number, email, and school. So this will help you to quickly test out the schemas and help you to extend these using these schemas. Then there are a few more files like Docker Compose, which has been automatically generated by the command. So this will be used to start all the services, and we also have a few other files that are required for the services to run. So now we have the services running here. So what we can do is we have an health API. So you can trigger that health API and check if all the services are running fine. So this will give out the complete status of all the services that we have. For example, notification service, signature service, encryption service, file storage, Elasticsearch, if Keycloak, if everything is healthy or not. So you can use this health API to test out, to check out the health status. So now moving on, let's set up the demo education use case that we have. So first what we need to do is we need to clone the demo education registry, the repo that we have. So the steps that I'm following here is also it's been mentioned in our docs.sunbird RC .dev website. The same steps I'll be following here as well. So once we clone the education registry, so I've just cloned that repository. So this repository has all the schemas that will be required for our use case. So let me show the list here. So if you see in demo education registry, there are 3 to 4 schemas that has been listed here, which defines the institute schema, the student schema, and the teacher schema. And there is scheme common.json. I'll just explain. I'll just open all of these files and show what these schemas represented. So before doing that, what we basically need to do is, so we need to move all of these schemas that we cloned from the repo to the respective path. So previously I showed you that the inside config schemas, there are few default schemas that the command has created. So first we can remove them and move all the new schemas that we have cloned from that repository. So I'm moving all the schemas that is present in the education demo use case and moving it to the config schemas path. So once this is done, we just need to restart the registry, because this is a volume mounted to this registry. We might need to force recreate the registry. So this is one way of creating the schemas, where you can keep your schemas as a file and mount that volume to your registry. Or you can also create the schemas using an API, where we have exposed schemas API. You can create schemas and manage it in draft and publish status and all of that through a API also. And also we have an admin portal that is coming up, so where you can create the schemas using an UI. So you don't need to worry about any JSON specifications or configurations or anything. So a UI will be available in, I think it's still in progress, and it will be available in sometime soon. You can use that portal to completely create your schemas and generate all the configurations that will be required. So now I have added the schemas and I have restarted the registry. So like we were saying before, so as and when we add the schemas, by default, the registry will start creating APIs for this schemas. So you can check this in the Swagger UI. So the registry exposes the Swagger UI, where all the APIs will be listed. Like we have seen that we have moved or created institute schema. So all the APIs for that institute schema, teacher schema, and the student schema are automatically generated, and we can use these APIs to manage those particular entities. So now we'll quickly walk through about these JSON schemas that we just created. So first is institute schema. So this has basically kind of attributes which will be required for this institute schema. So we have institute name. So it is type is string and the minimum length is 5. So if the user is not adding the name, if the name is less than 5, it will throw validation errors. And we have fields like establishment year, which is an integer, and we are saying that the minimum should be 1950, which basically says that the value should be greater than 1950. If it is less than that, it will throw error when that entity is getting created. So also you can see that there is a contact number. We can also create regex patterns. For example, here we need to validate it's a valid Indian mobile number or not. So I put a regex here which says the number should start from 6 to 9, and it should, after that it should possibly have 9 more numbers. So all of like this, the validations can be added. So here you can see we have defined a string, then there is an integer example for an integer. Also, you can feed in a enum set of values, so which basically means that this school type can take only values from this list. It could be boys, girls, or co-ed. So you can define an enum list also to the fields here. So it could also be an array, so where you can define an array, and internally you can define what should that type of that independent item should be. It can also be an object. For example, here we are saying that affiliation is an object which has few more properties. So in this way, you can keep creating nested objects. It's not like just the schema should be flattened. It can be nested as well. So it can go to any level. So you can keep adding nested objects. So you can see there's one more example here for enum. So this is about creating the schema. So once you have created the schema, so the schema specifications, then we can add the configurations. So like I said, we can add access specifiers here. By default, like I said, all the fields are public. So when anybody makes a discovery call, all the fields will be visible to the external user. So I'm mentioning here certain fields needs to be private. For example, contact number and email needs to be private. So which means that discovery APIs will not return back these values. But if somebody is interested to see these values or to see these values of these properties, they can raise a consent, and if the user approves it, then only they'll be able to see this contact and email. So there are few fields like admin email and admin mobile. Even with consent or any other access, it might not be required for someone to see that value itself. So those properties can be added here. So you can define the path of that attribute. So basically, dollar is the root. From root, you are saying that contact number is one property that should not be exposed publicly. So you can, even if it is a nested attribute, you can keep mentioning address dot city, address dot um, state, something like that. So then we can talk about the index fields. So here you will list out all the fields that will be required to be indexed. And right now in this scenario, we don't need any index field, but we need a unique index field. So I'm saying that institute name should be unique, and it also needs to be indexed so that whenever somebody is searching by the institute name, the search will be faster. So then we have an option to add the system fields. So these are the fields that will help you to add like something like an audit field, like who created at, who updated it at what time, who did this entity been created by, then who kind of updated that entity. So all of these are pluggable. If you don't want these fields, you can remove it. By default, it is not added, and it is you need to specify if these fields are required. Then attest.
So are these the only 4 system fields, Tejas, or are there more?
No, these are the basic auto-generated system fields for now.
Okay, so basically implementers can choose to use them or leave them out.
Yeah, yes.
And about index fields, can you also kind of quickly give best practice in terms of, so if you're looking at, so this is the, so this is the institute schema. So for institute schema, what could be some index fields that could be set up? So
yeah, so basically
ease of searching, right?
Yeah, so one quick example is institute name itself. So since I've already added Unix index field here, I'm not specifying it again here. So one unique index itself will create an index. So institute name, because a lot of searches will be happening on the institute name. And for example, if there is a query,
we have a field for boys, girls, and co-ed. So that could be could that be an index?
Yes. So we need to specify the field name, the property name of it here, and it will create a index on that column.
So essentially, I mean, so typically in RDBMS design, the thumb rule is that wherever you are going to do where queries, you add indexes to those columns. So similarly here, the fields where we expect to do a lot of lookups or search filters, those fields could be as index fields. Is that the
right line? Yes. Yeah. So this index field will be applicable only if you are using only the primary data source. So we are shipping Elasticsearch also as an optional thing where you can add that. So if you are using Elasticsearch, this will not be applicable. So anyway, Elasticsearch will already index all of those fields and out of the box.
So this applies only to Postgres or the RDBMS.
Postgres, yeah, yes. Okay, so continuing, so we can also talk about mention the attestation policies. So we'll skip this part because we'll be talking about this in detail in the next webinars. So this will take a lot of time. So attestation policies can be defined. And the next thing is roles. So we have 2 types of roles. One is for invite and completely a role that can be used for managing the complete schema. So invite roles, I'm saying that anonymous. So institute can be when we say anonymous, anybody can come and self-register. So nobody else needs to invite someone to join institute. So there is no permission required. Whereas teacher, when I move on to teacher, I'll show that a teacher can be invited only by an institute. So those specific roles can be added here. So there's another field called roles, which will basically help you to create, specify the roles here, which will who basically only those users with these roles can manage this complete entity. And then we have ownership attributes. Like I said before, this will be used to generate login credentials. So we need to define the parts of where this data will be present. For example, to uniquely identify this user, what is that field I can use? For here, I'm using email as that field. And where is the mobile number part? So basically, each one of you can represent schemas in different ways. So we're giving out option to specify where exactly the mobile number is stored. So you need to define. So some use cases they might store it like contact details dot mobile, contact details dot email. So they need to define that path. Where is the email field? Where is the mobile number? So here we have given an example to show that multiple logins can be created for the same entity. If you want some 2 or 3 more users to take the ownership of a particular entity, then multiple ownerships can be created. One of that example will be like, for example, a student schema, where a student can himself be a owner or a guardian can also be an owner of that entity. So for in those scenarios, we can specify first the student details here and then the guardian details here, so that both two logins will be created for them. So both of them can log in and manage that particular entity. So quickly, I'll just talk about teacher. I'll not talk about the definitions. So it's the same schema that's available on our repositories. So we can check that there. Here, I'll just talk about the invite roles. So here you can see that invite roles is mentioned as institute. So here we are putting a condition that a teacher can be invited only by an institute. So they can't anonymously come and self-register, or anybody else cannot kind of invite. A student cannot invite a teacher or any other roles. So these are the roles, or you can actually define the institute name, define the schema name here. So if you have a student schema, and if you want student schema to be invited only by a teacher, so then you can mention something like this. So student schema can be invited only by a teacher. So here, I think this will cover most of the schema and schema configurations. So the same details is available on our website, so we can check the details there as well. So now moving on. So I've added two schemas. Whatever I've shown you now, I've added the schemas to the registry and I've restarted it. So now I'll open the Postman collection. So the same collection is available on the demo education use case. So you can use that to try out the same flows. So the first API, which is an health API, which has been exposed to show the health of all the services that we have. So the next API is Swagger JSON. So by default, it's a dynamic Swagger JSON that we generate based on the schema name. So you can use this to generate Swagger UI, or you can use this for exposing your APIs to the other services or for other developers. So now we saw the Swagger UI. So next is, let's start with how do we invite a user. So we generate RESTful APIs. So to invite a institute, so if you see the URL, it says API v1, the schema name, basically institute / invite. So here I've added very basic fields here. Institute name, SVG, establishment year 195. So basically this is an not a valid data. If you remember in the schemas, I said that institute name should be minimum 5 characters and establishment year should be minimum 1950. So year should be more than 1950. So let's call this API. So if I trigger this API, you can see that the validations exceptions are thrown here. It says that institute name expected is minimum 5 length, but actually it was 3. Similarly, multiple validations have been thrown. For example, contact number is not as per the pattern. Establishment year is not equal or greater than 1950. And the email field is also not a valid email address. So validations like this can be applied onto the schema. So the exceptions will be thrown as and when the API is triggered. So next, let me call the invite API with valid data. So I've corrected the data here. So if I trigger this API, so you can see that the institute invite API is successful. Once it is successful, you can see that it returns back a OS ID. So this is equivalent to your primary key kind of ID that has been generated for this institute. So this is the ID. So now let's move on. Now what I'm trying to do here is, if you remember in the institute schema, I had put a unique constraint on the institute name. So we go back here. A unique field constraint was added on institute name. So if I invite a new institute with the same name, it should throw a duplicate error. Okay, so if you see here, because the institute name was duplicated, it throws that exception here saying that the duplicate key value is violated. So this error will be thrown. So this is how the unique constraint will be applied. So then I'm moving on. So in this API, I'm going to create another institute with a different name and mobile number and all of it. So as and when these institutes are invited, right? So the respective user credentials will be created on Keycloak. So the institutes can go log in with their credentials, with their email or contact number, and then they can manage their entities. So I'll also show that flow. Before that, we'll see how this discovery or the search API works. So if you see all our APIs, institute schema name will be defined, and then we are saying search. So this is the search API that we'll be using. So here I'm not putting any filters. So filters are your where queries that can be applied, and then you can also apply a pagination. So I'm just putting an empty search condition here. So basically I'm doing a select star with a limit and offset. So you can see that both the institutes that we created is returned back. So you can like use the pagination to, if you have a lot of data, you can use this paginations to page through your responses. So then I'll just talk about few search filters that has been supported. So for example, I want to search all the institute names that is start containing SVG. Okay, so it will return back only those institute that matches this constraint. Okay, so if you see here, previously I talked about access specifiers. So if you see here, this institute schema is being called without any authorization. There is no token passed or anything. So if you see here, only the public data is returned back. If you remember, I had sent institute name, establishment year, contact details as well, but those details are not coming back because those details are mentioned as private and internal fields. So that will not come back in the public search queries. So only the public, by default, all fields are public, only if it is mentioned as private or internal. So that will not be returned back in your search queries. So just to show back, the institute invite add 4 fields, name, year, contact number, and email. Only 2 fields are coming back, like institute name and establishment year. Contact details like email and mobile are not coming back. So next we'll talk about certain fields that is auto-generated. One is owner. The Keycloak user ID is being stored here. This defines who the user ID of that particular entity. And like I said, we also generate system fields. Like we had mentioned that we need both timestamp and the user who created or updated it. So we are storing that both the details here. Who created it and when was this updated at? Both these timestamps have been configured here. Then OS ID. So OS ID defines the, like I said, it's like primary key. This is the OS ID for this entity. So we call it as OS ID, and this is the value of it. So next we'll quickly talk about a few more filter options. So we support search filters like contains, starts with, for example, I'm saying starts with SV. So it will return back all the data that has institute name starting with SV. So also I can say add filters like greater than, less than, greater than or equal to, less than or equal to. For example, I want to see all the institutes which are established after 1990, year 1990. So I can put this condition saying establishment year, what is the field name, what is the operation and the value, greater than 1990. So it return back only one institute, which is 1995. So I can also say greater than or equal to, GTE. So it returns back SVG also because it is matching the equal condition, and 1995 also because it is matching the greater than condition. So similarly, less than or less than equal to is available. So then the other operation is equal. So where I'm saying that establishment year should be equal to 1990. So this will return back the 1990 matching response. So I can also say not equal to. So when I say not equal to, it will return back the institute which is not matching 1990. So this is the response of it. So this is all regarding the discovery API. So now moving on to the uh, creating the token and taking the ownership of that institute. So I'm using the KeyClock API here to generate the token. So I'm passing the institute's email ID and the password that is automatically generated. So this is the default password that is generated. So a token is being generated now from the KeyClock. So now what I'm trying to do is I'm going to get those details. If you see here, I'm using get API, API V1 Institute. I'm passing the token that I just generated. If you see here, I got the institute details with the token. So because I am the owner of that institute, all the details of that institute is returned back, like year, institute name, and email and the contact number both are been written. Because I'm the owner of that institute, all the details, public, private, and internal, all the fields will be returned back. So now let's see how do I update these details as a owner. So the API is institute/institute ID, and in the body, I'm trying to add few more details like address. So this will be appended to the current data. So you need to pass all update, delete, all of these operations requires token. They must be the owner of the document to make any changes to that entity. So now I'm triggering the update API. So you can see that it's successful. So now let me get those details. Previously only 4 fields were there. So now I'm triggering the API. So in this, if you see, the address field is appended. Address field is appended and the remaining fields are still there. So this is regarding the update API. So now I'll just do a search call. So you can see that newly added data also will be coming here. So for the first schema, you can see that first entity, you can see that that address field is present here. So now I have added an address field just to show how to search with nested properties. So I had added an address property. Inside that there was a field called state. So now if I want to search on nested properties, so I can use something like address dot state. Like you can keep adding those properties in a nested manner. So I'm saying address dot state should be equal to Karnataka. So all the entities that are matching these conditions will be returned back. So I'm saying address dot state should be Karnataka. So once this condition, based on this condition matching the responses, you can see the respective response here. So this is how we search on a nested property. So next is about the delete API. Similarly, institute name and the schema name, which is institute and the institute ID. The owner, the token should be present here. Only the owner of that entity can delete that entity as well. So that successfully has been deleted. So now that complete data will be removed. So even the get APIs will not return back. It says entity is not found. And even from the search, I'm doing an empty search here without any filters. So this should also not return, will not return back that SVG institute that was created. Only one institute is written back. So it will be deleted from all the data source. So this delete is a soft delete. So a flag will be turned on for that respective entity. So if you want to turn it, like if you want to revert the soft delete, it needs to be done manually. So now let's talk about the roles that we had. So we said that a teacher can be invited only by a institute. So here I'm calling the teacher invite API, and I've added few details for the teacher, and I'm not passing any token. So if you see that there is no token passed. So let me trigger this API. So you can see that user is not allowed to perform the operations on this entity. Automatically, this will be blocked by the registry because we have clearly mentioned that invite can only be done by an institute. So now what we need to do is we need a proper token, institute token needs to be passed along for this API. So when I trigger this with a valid institute token, the teacher gets invited. So you can see that the teacher has been successfully created. Now I'm doing a search on the teacher schema. So teacher/search. I'm putting there is no filters, an empty filter. So they should return back the teacher that was just created. Okay, so this is all the APIs that we had to show. So the same set of Postman collection is available on the demo education instance. So you can check that. So you can go to our website, and on the left hand side, you can see some sample use cases that we have listed, and there the complete steps to install what I just followed is all mentioned there, and the API collection is also mentioned there. So now moving back to, so if there is any questions, you can raise it onto the QA. So we'll answer it in some time. So we just kind of go through the next set of things that we have. So Ashwin, do you want to continue? So just
Yeah. So, so what we saw now is basically how to create schemas, how to kind of configure some key attributes of the schemas, like uh, the fields, the audit fields, how to kind of configure roles and all of that. So this was just a, I mean, this was just an intro to writing schemas, and as you've seen, it's pretty straightforward. There are a few kind of specific fields that can alter behavior of schemas, and they just talked about those, and all of those are also documented on the website. So you can go through the docs, and then again use the forums to reach out to us in case of any further questions. Of course, we'll make a point to answer all the questions out here already. So that's that, and I think once the basics of the schema are clear, then I think you can kind of get into defining your own schemas. So what I like to call out, and I think that is also one of the question here, is that how do you kind of get started with instantiating a registry? So the way I would want to encourage people to think about a registry is, of course, a registry is much more than a database, but principally think of it like a database. So you would start by thinking about your entities, your ER diagrams, how are the entities linked, what kind of actions or workflows do you wish to enable. So is it so which entities can self sign up, which entities need to be invited, what are the linkages, then what are the typical workflows, or so can who can edit their own profile? So can students edit their own profile, or can only institute edit their profile? So that will kind of give you a indication of how your access needs to be set up. So this is kind of a precursor to the design, and then getting into details of each schema. What are the fields? What are the field types? What are mandatory fields? What are optional fields? What is the validation that you need to apply? Like they just talked about phone number validations, all of that. So that is how you would kind of eventually come to the schema design. And then once you have the schemas, then it is just a matter of initializing the registry using any of the existing mechanisms. So you could use the Docker Compose file that is already provided, or you could just take the services and deploy them individually. So it's up to you to really kind of take that forward. But the key thing is to get to the schemas and to really define your use case in a very crisp way, build the schemas, and then install and initialize the schema. So that's how I would encourage everybody to kind of look at installing. So yeah, so that said, we are kind of at the end of the demo or the explanation section, and we will use the next few minutes to answer all the Q&As here. While that happens, while Tejas is kind of responding to a lot of the questions, and thanks everybody for kind of liberally sending questions. We will try to answer as many as we can, but if not, we'll definitely post these Q&As on the forum and try to answer them there. So the next two webinars also we are looking at dedicating into tech deep dives. So right now we covered the basics of schemas, how to write schemas, how to kind of put fields, the visibility, all of that. In the next webinar, we would deep dive into the workflow aspect, which is where you would be able to write configuration for claims, attestations, and have, for example, initially I talked about an institute attesting the claim of a teacher. So we'll get into that. That's webinar 4. And then webinar 5 will go into VCs, where we will be looking at Sunbird RC as a VC issuance platform. So that's the kind of quick thing about the next two webinars. And yeah, so thanks everybody for attending this. I think now we'll probably spend a few minutes to respond to the questions. Thank you, everybody.
So I think we'll just
Tejas,
go
do you
through.
want to? I mean, there's one question about linking schemas. Do you want to quickly talk about how
Yeah.
these can be linked?
Yes. So regarding linking, so there are different, it depends on the design pattern that will be required on the use cases. So let's say there might be a use case where institute, when he invites the teacher, he still needs permissions or access to even manage the teacher entity. So right now, if you see invite, what is the difference between invite and just creating that entity, right? So the difference is invite is basically you're inviting a particular user to join the registry and you are not taking up any ownership. So there is an API called just to create an entity. So there, the difference is the whoever is creating that entity also holds that permission. So if the institute wants to also have ownership on the teacher, so then it should not be an invite call, it should be a post create call. So where the roles, like I showed the invite roles and roles. So instead of putting institute in invite roles, it should be mentioned in the roles section. So then the institute who created that will also have access or will have the capability to manage the uh, teacher or the student entity as well. The other references would be like, for example, they want to just create a reference, for example, wants to say that a teacher studied in a particular institute. They might require a kind of a, in typical database, a foreign key kind of a lookup. So you can't imagine the same way here, but similarly, you can store the respective reference OS ID, which is basically the ID of that institute or the teacher in the respective schemas. So currently, we don't have a lookup when you're searching, but that's in our backlog to explore that and see if we can do lookups based on this reference IDs. But manually, you need to set that reference ID, maybe like institute ID in teacher, to say that this teacher has been working at this particular institute. Yeah, that's about the linking.
Yeah, thanks. Do you want to quickly also answer about the auditability? So Ghanshyam is asking, is there auditability support when any records are being edited? So is there an audit trail?
Yes. Yeah. So Sunbird RC provides, I think I missed out with the two functionalities. One is encryption and audits. So we do support audits. We have log-based or database based auditing. So when you enable by default auditing, right? So all the actions that are taking place on the registry will be logged onto the log file. So you can set up an ELK or any stack similar to it and read all of this and store it in your Elasticsearch, or you can use the database support that we have, which where we all store this actions of audit that is happening on an entity in a database. So it basically stores all the audit there, and you can check that. Basically, it's similar to a schema that will be created for the audits. So we can use get those data from there. So we have both log based or basically store it back in the registry itself. And also regarding encryption, I saw someone had asked that question. Yes, private fields can be encrypted. Only thing is the encryption service, generic service is not provided. So you need to expose an API where those fields will come to your service and return back. You basically need to return back the encrypted value of that. So that service is not provided as of now, but we are planning to add that as at least a generic kind of a support. But encryptions are available. You can encrypt and store the values, and when it is kind of returned back, it will decrypt and return back the values. So basically, you need to create a service with encrypt and decrypt APIs.
Great, thanks. So I'm just kind of trying to look at a few questions and yeah, so Giriraj is asking, is there any extensions available to add verification steps of the contact number? So maybe here, do you want to talk about the Aadhaar uh,
Yeah.
kind of plugin that we had and how those could be
Yeah.
extended?
Yeah, so this is something on the attestation side, but anyway, I'll just give a quick information about it. Yes, we can do this external verification. It could be contact number, GST number, Aadhaar number, or any MOSIP identification as well. So you need to set up that configuration, what we were talking about attestation policies. So we need to first define that, and a small service needs to be created because these are third-party things. So you need to write a small Java code which kind of validates that information. Maybe it can validate it from GST or Aadhaar or any other third party. If, for example, contact number, you can create a SMS or some kind of OTP layer. So your attestation flow can help you to verify those data. So this could be auto, I think we'll talk about it later. So it can be automatically triggered, these attestations when a mobile number, GST number is added, it will automatically trigger this verification steps. So we call it as attestation workflows.
Cool, thanks.
So I think I saw somewhere a question regarding can we modify, just searching for that question. So can we modify once the schema is created, can the schema be modified? So there are two parts for it. You can create new fields. So you can go, let's say there were three fields, name, age, and maybe address. So now you want to introduce mobile number or email ID. So you can introduce that. What happens for the existing thing is you need to handle it manually. The existing data that is already present needs to be managed manually, maybe setting default values or adding the exact values for that. So, but you can't change the existing types. For example, if there is date of birth, you might have initially put it as string, but later you feel that, sorry, not date of birth, age field was string, but now you want it to be number instead of string for the age, right? So that cannot be done because the database, all of that is already created. So migrations are not automatically generated. So manually migrations needs to be taken care, and the schemas late once the migrations is done, then the schemas can be modified.
There's one more question about SQL injection. I'm not sure what. So I think
Uh,
probably is because we have a
yeah, I think
MS back database. Uh,
yeah.
is Postgres is SQL injection and validated. So
No, the
right.
from the APIs, we're not actually taking the SQL queries directly. If you see there, it's a custom queries that we support. There are only I think 5 to 6. I think most of it I have shown it. Only those specific operations can be used. Custom queries, SQL queries cannot be added.
Right. Right. So maybe I think one quick about the login and how the role. So there's a question about how does the login roles and the actions work. So maybe you want to quickly give an example of that. So for example, the roles are picked up from the token, right?
Yeah.
So maybe just kind of uh, explain that
Okay.
in a little more detail.
So yes, so roles, if you see that in the example we mentioned, a teacher can be invited by an institute. So when we are triggering the institute, the teacher invite API, right? So we need to pass a valid token. So it's a JWT based token that is being sent. So for example, I was sending the same institute token. So basically, this token, when we uh, check the values of the data that is present inside this JW token, you can see that there will be a roles field, and that roles should have that particular role that you have mentioned there. So institute should be present, for example. So here you can see that Williams roles is institute. So right now, there is a dependency on key clock. Right now, we are also working on a story where we are creating a generic layer. Any auth to based service can be attached. So we are completely removing the key clock dependency. So you can attach the any other auth system that you are already using, and basically that token that has been generated should have a roles, and this role you can mention it in your schemas.
Cool. Thanks. So any specific questions you want to take up? I think we're actually over time. Any
Yeah.
specific questions you want to take, or maybe the other option is we can put all these questions on the forums and we could just answer them
Yes.
ourselves.
Yeah. So just want to highlight that we have. Yeah, I think there is a page question on pagination. Yes, we do support pagination. Like in the search API, you can pass the limit and offset. Limit is basically the number of records you want to see, and the offset is like the page number wise, like offset from which offset you want to read the data. Okay, so we are also so basically these are the links to our website and the Discord channel. So you can join the Discord channel. So the links are also present on the website docs.sunbirdrc.dev. So you can join the channel there, and all the community members are present there. And if you have any specific questions, you can raise it there or on the GitHub community dashboard as well. So you can raise in the discussion uh, in the portal. You can just raise a question, and any one of us will actually reach out to you. So the complete steps regarding installations, APIs, all the information is present in the this documentation website. It's in progress. If you think if there is anything missing or if the data is not correct, so you can just raise that issue also, so we can update that.
Great. So thank you everybody for joining in today. Really was glad to have everybody here, and all the questions really that really help us validate that there's a lot of interest, there's a lot of enthusiasm around RC. So thank you, and then we look forward to everybody participating in the next webinar. So I'll just repeat the open questions that we could not answer right now. We will post them in the forums, and you could look forward to kind of just subscribe to the forum so that whenever there's a new question, you are updated, and you can keep an eye on when we answer. That's right. There's right. That's how we'll.
Yes.
All right.
So
Okay.
also you can check on our LinkedIn portal. So there, if the next webinar dates will be published there. So the next webinar will be continuation on this. So where we create attestation flows to verify or basically attest or kind of verify the data, and we generate verifiable credentials. So watch out on the portals, on the LinkedIn, on social media handles basically. Cool then.